Now, when we talk about IoT, security is not the only thing. There is a lot going on, and one big area is improving efficiency. So our next presenter will talk about improving efficiency. We've talked enough about security, and we are scared enough, right? We'll talk about now improving efficiency. Karl Zimmerman is here from Florida. He's CEO of EnergyIQ, a very smart individual. Don't be fooled by his title. He's CEO, but he's a hands-on engineer, very technical. He has made some cutting-edge applications. He's worked in integrating microgrid with desalination plants, with chillers, and with security systems. He's done it all that. So he is a great technical innovator in his area. As much as I will say will not be enough for him. He is also our local lad. He's a Penn State graduate with a degree in mechanical engineering. And that's why he likes to come back, because when he comes to present here, he can go visit his family and friends. He's also a member of a curriculum board at the Penn State Hazleton campus. Very qualified, very learned person. He was previously vice president of engineering at Integrated Building Technologies, where he was responsible for design, installation, and support of network-based direct digital control systems, security systems, fire alarm systems. I think we should learn fire alarm system from you. Karl also served, now should I say 1990s? In 1990s as manager of facilities at Sensormatic, which is a Fortune 500 company. Please welcome Karl Zimmerman.
Thank you, Harun. Thank you, Harun. It's always a pleasure to come back to Harrisburg. I get the inevitable, enviable position of being the presenter right before lunch. So my presentation is going to be 3 minutes long, and we'll get out of here really fast. Harun did mention that one of the fun things I get to do is I'm on the board of advisors for an engineering curriculum at Hazleton campus at Penn State. And every year I do a presentation for the seniors, and I talk to them about something that Jack mentioned about the whole concept of conquering versus exploring. And I always share the story that when I graduated from high school in 1980 when I was 4, and so I always tell them about what happened from 1980 to 1984. I don't know if anybody really knows this, but when I started college, my first computer class was with punch cards. And if anybody knows what punch cards are, they used to make Christmas decorations. You know, we did back then, spray glitter on them and stuff like that, made wreaths and everything. But there were no cell phones, there was no internet, there was no fax machines. During those 4 years, the first artificial heart transplant came in. The space shuttle took off, all kinds of technology things. Apple computers, IBM developed the first personal computer. All these things happened in such a short amount of time. So one of the things I like to tell the students is make sure you are exactly what Jack said. You're looking forward, because if I didn't look forward when I left college, I would still be, thinking I'm working on punch cards and things like that. So you always got to keep innovating. And one of the things that we look at is how things are changing in the world and how people relate to technology. Just a little side story is any Marines in the room? Okay, we got one Marine. My son, my 18-year-old son is he's in Marine basic training right now. And what do you think the first thing was that he was worried about? He wasn't worried about a drill instructor beating the heck out of him for 13 weeks. He wasn't worried about dirty clothes and crawling. He was worried about not having his cell phone. So he's in the middle of learning what it's all about right now. So where we play, being a systems integrator, we started out in the building automation space years ago, and as that became much more commoditized and as things started spreading out, we got involved in a lot more of infrastructure. So about 10 years ago, I partnered with a company that was a former Florida Power and Light executive. He owned another company, and we started doing a lot of work in the power industry. So if you look at a typical smart city, oh, thanks, Arun. A typical smart city, what is a common denominator besides cybersecurity and communications is power. And another thing that I have to clarify with everybody is that there's a difference between power and energy. A lot of people, even engineers, I've read reports where they're mixing KW and KWH and not understanding the difference. So if you look at a typical utility, and if you look at a smart city, and everything in there is using power. The tunnels, there's power in the tunnels, there's lighting, there's rail, there's city street lights, there's traffic signaling, there's buildings, there's industry. Everything uses power. The utilities, what they won't tell you, they're a dinosaur industry in a lot of ways. Unless you're in California, they're a little more progressive out there, and some other parts of the world, other parts of the country. But what we find is that understanding what the utilities need in a microgrid or in a city is very important. Typically, utilities don't want to sell you less kilowatt hours. They don't want to sell you less energy. They would like that power line, the KW line, to be a nice flat line, because what they don't want to be doing is turning on turbines, turning off turbines, adding and deleting equipment to be able to provide some kind of a demand level for you. They want to sell lots of kilowatt hours, but they want that line to be nice and flat. Well, that's not reality, especially now that microgrids are coming into play, renewable resources, things like battery systems, wind and solar, which are very dynamic over time. So one of the things we get involved with is how do we take this demand issue and this energy issue, again, demand being a real-time magnitude measurement, and energy being something you consume over time, the bucket fills up over time. How do we deal with those things in a city? So I'm going to cover 3 basic concepts of how we're going to focus on demand management in this presentation. So demand management is basically that instantaneous spike that you're trying to deal with, and it could be within a building, it could be within a campus, it could be within a city. And a little side note is the whole concept of a microgrid is, everybody's heard what a microgrid is, and everybody probably has their opinion what a microgrid is. What my vision of a microgrid is a logical collection of power producing and power consuming assets. So it can be in a building, it could be a campus, it could be a city, it could be a country, or a state and a country. For example, you could say the state of Texas is a big microgrid, because Texas is isolated from the rest of the country from a power grid perspective. They have a border around their state, and they are what they are. They don't move a lot of power in and out. They have their own regional balancing authority. So one of the things we like to do is at first understand what's our logical collection of objects that we're trying to do. So the 3 basic things when you have an entity that's you're using your power, and there's 3 things we like to focus on. One is how can we reduce this demand, and one of the methods is through just energy efficiency. Out in California, there's a concept called net zero energy, which is you basically want to produce and consume, you want your energy to net out at 0 at the end of the year. Again, very energy focused, not necessarily demand focused. But some of the concepts with net zero energy allow you to reduce the demand in your building because they have cool roofs. There's a lot of things they have to do to the envelope of a building to make the energy usage, to make the power usage actually a little bit lower. Another thing we're going to talk about is demand response. So anytime there's power being consumed by something, whatever it may be, it could be a set of rail, it could be a building, it could be a factory. If we want to reduce demand instantaneously, there's some pretty neat things that are going on right now of how we can address those. And finally, a third topic I'm going to talk about is something called distributed energy. What we'd like to be able to do is dispatch other energy assets that's maybe something that uses natural gas or something that uses hydro or something like that, where we can go into some different assets to offset something we're trying to prevent. Okay, so if we talk about energy efficiency, Take a typical building. The previous presenters talked about something called demand control ventilation. One of the things you can do in a building that consumes a lot of energy is ventilation. And there are certain standards that are presented by an organization called ASHRAE for the amount of ventilation that's supposed to be in this room, for example. If it's 20 CFM a person of outside air, but what happens if there's 4 people in the room and there's not 200 people in the room? How do you deal with that? So there's some things we can do with control systems to reduce that demand overall by just optimizing the amount of ventilation you're bringing into a building. There's other reset strategies you can use on equipment. So if you don't need something running a certain speed, you can back it off based on the demand in the field. Piping, airflow with fans, things like that. Another one is something called cogeneration. Right now, if I was to have an electric chiller producing chilled water to run this building, my efficiency would be maybe 40% or something like that of use of that energy. Where we can use cogeneration, which is what this facility does, is where you take natural gas, you use a turbine, you produce electricity, and then you take that waste heat, and then you run it into an absorption chiller that will then use that waste heat to create the chilled water. So now your efficiencies are much higher. So that's another way to reduce the demand of the profile of, say, of a building like this. And the last one I want to talk about is the net zero energy projects. California has a mandate. Now California is always way ahead, whether right or wrong, of the rest of the country. California has a program called net zero energy. And by next year, any new home designed in California has to be net zero compliant. And what that means is that they have to have some type of renewable energy generating device on their property. So you build a house, you have to have wind, solar, some type of thing that will produce energy. And then you have to design your building to be so energy efficient that what you use, sometimes you're pushing to the grid power, sometimes you're pulling from the grid. At the end of the year, it's got to net out at 0. So they're mandating that all new homes have to be designed that way. By 2030, all new commercial office buildings, commercial properties have to be designed to be net zero compliant. So California's way, way out there now. That creates problems for them. I don't know if you've ever heard of a term called the duck curve. So what happens is during the day when all this solar is being used, their output of the utilities is way down here. So it starts high in the morning, goes like this, and then it heads back up at night when everybody turns things on, and all of a sudden there's no solar. So the utilities have to deal with these ebbs and flows of the energy output that's required. Another challenge is wind, big time, because if all of a sudden the wind stops, you could lose gigawatts of power just like that. Within 15 minutes, you could lose what you typically have in major power substations. So it's a very critical issue. On demand response itself, so again, one way to reduce the consumption or the demand of a certain entity is with energy efficiency. So you design things properly, you bring your overall load down. That's not something that's instantaneous, though. That's kind of a long-term profile. One of the strategies we have is called demand response in dealing with instantaneous problems. And there's a lot of different ways to deal with demand response. One of the things you can do is there's 3 basic terms we like to use. One is called peak clipping. So basically, your utility bill is typically broken into 2 parts. It's your consumption, which you pay over time, and then you get hit with a demand fee on your spikes. And again, the problem with the spikes is the utility has to have what they call spinning reserves sitting there waiting, that if all of a sudden you turn on 50 toasters, they got to be able to provide you that power. So they have a certain percentage, they just sit spinning and spinning. It costs them a lot of money to do that. So what they do is they pass those fees on to the consumer. So in a smart city, and you're trying to manage your demands and your costs, you're always looking for ways to clip those top parts. So again, one way is clipping. Another one is load shifting. So we may shift something from a peak period to an off-peak period. So say you have a manufacturing process and you're crushing cars or something. We have a customer in California that is that they grind up automobiles. They're a recycler. And they can take a school bus and grind it up in about 3 minutes into a bucket of scrap. It's pretty interesting to watch a school bus get eaten. What they do is they never do this during peak times. They have a certain window of the day, say 4 to 6 p.m. or 3 to 5 p.m., where the utility says your rates are really, really high during that period. So what we try to do is we try to shift around those things. And the last one is valley filling. That's more of what they call duty cycling, where we can strategize where if something needs to run, say, 10 times a day, and you have 5 of them, we try to stagger them. So they're not all peaking at the same time. We can kind of alternate how they run. We can do that with compressors and things like that, and air conditioning and stuff like that. So that's some ideas on the demand response side. Another area we looked at, again, as I talked about, is something called distributed energy resource strategies. This is where we get into more of the microgrid business and some things going on with natural gas and stuff like that. So in a typical microgrid, you have a couple of components. You typically have a utility power source. You're going to have some kind of a renewable energy. You're going to have solar, you're going to have wind, or something that's using from Mother Nature. And you may have a battery, some kind of a storage device. So what we try to do is we try to optimize the usage and the value of each of those components. So when is the utility the right time? Obviously, the utility is the right time to use at the lowest rate. So utilities may be nights or off-peak times. We want to use the utility depending on the cost per kilowatt hour. We like to use the sun whenever we can. The challenge with the sun is that, well, we may not need all that energy when the sun's out. So what do? We introduce a storage component, which is a battery. So we'll take the energy when we got it, we'll dump it into the battery. And actually in some areas in California, it's mandated from the utilities that you're not allowed to charge a battery from the grid. You got to charge it only from PV. So there's a lot of strategies we put in place that when the sun is out, we're using the sun energy to charge the battery, and then we use the battery for our clipping. So there's a lot of strategy you can go in there. Wind is another one. Again, like I said, wind and solar are very common to use to store energy in batteries. Another concept we're working with is something called base-loaded natural gas generators. One of the challenges with traditional generators is cost per kilowatt to produce energy. With diesel, it's kind of expensive. In Pennsylvania, with the proliferation of the natural gas business, one of the things we're working with the state of Pennsylvania on is how do we utilize all this natural gas we have? Because right now what's happening is a lot of it's getting shipped out of the state, and we want to be able to, in the state, we want to be able to use that natural gas in a much more efficient way, but use it internally to benefit the state. So one of the things we're developing, we actually have it finished and we're working with Phoenix on the control side, is a natural gas generator that's EPA compliant to run more than 100 hours a year. There's rules for emissions that a standby generator can't run as what they call prime power. Prime power means you can run it for 87, 60 hours a year. Standby generators are limited to what they call 100 hours a year because of the crap that they put out in the emission stream. So we've developed a highly efficient catalytic converter that qualifies the engine to be EPA compliant in the most strict areas of the country, which is Southern California, San Diego area. So we can actually utilize these natural gas generators as base-loaded devices that during peak periods, whenever the peak is coming up, and we're on what they call a peak period or a super on peak period for the tariff schedule for energy, we can turn on this natural gas generator, and instead of paying 20 cents a kilowatt hour, 22 cents a kilowatt hour, we're making it for 9. So it's a very efficient way of handling that. So, and we're actually adding those into the microgrid world because sometimes solar and battery aren't always going to work. Because from a cost perspective, whenever you're taking the sun energy and putting into a battery, or if you are charging a battery with electricity from the grid, you have a double conversion loss. So you got losses going into the battery and you got losses coming out of the battery. So it may help you on the demand side, but on the energy side, you're actually losing, you're paying a little bit more. So we like to use these generators as a third option for propping up microgrids as well. So these are just some concepts that we like to talk about to kind of level set all the different things that are going on the energy side. And again, in a typical city, you may have multiple microgrids talking to each other. You may treat the city as a microgrid, as a whole entity. There may be pockets that of different systems that you would want to coordinate together. We talked a lot about the cybersecurity side, and really in no place is cybersecurity more important, I would think, than the energy sector. We know that there's a lot of things going on with that. So a little bit about the demand management architecture that we've implemented. Again, this is based on the Phoenix Contact ILC and the Niagara 4 platform. We can take a signal from a utility that says, this afternoon from 4 to 6 p.m., it's 95 degrees outside, and we know we're going to have a capacity problem between 4 and 6 p.m. because everybody's going home, turns the air conditioner down, or there's things that happen different times of day based on consumer usage. So we'll get a signal. It'll come through an SSL connection, a secure connection from the utility. We take it into our system and we go, okay, based on this facility, what are we going to do? Does it have a microgrid? Are we going to dispatch a battery? Are we going to increase our solar? Maybe not increase, we can't control the sun, but we can control the amount of power the inverters are putting onto our grid. Do we want to start a natural gas generator? So there's 1,000 things we can do. And the advantage of the Niagara platform in this business is that we're able now to give the utilities many, many more customers in this demand response market. In the old days, what they used to do is, remember, these are utility guys, and they see a meter. They don't see anything behind the meter, they see the meter. And they go, okay, it's spinning and I want to be able to do something. Well, I'm going to click a relay. Some of you may even have this at your homes, turn off your water heaters or your heat pumps or something like that. What they'll do is they want to click a relay and start a standby generator. That's their mentality. Well, not everybody has a standby generator, but if you have an automation system that can also reach into the building or into all your infrastructure and do things with that. We have a client in New York City. It's the Marriott Marquis in Times Square. It's the largest hotel in Midtown. And the way we got started on this is the utility came to us and said, we want to do all the Marriotts. And they said, well, most of the Marriott, the engineers, the chief engineers go, you're not touching my stuff. It's hospitality. My customers are the most important thing in the world. I'm not going to let some utility come in and just start my generator that happens to be behind the check-in counter that makes all kinds of noise. You're not touching my generator. So they were losing out, the utilities were losing out on customers for demand response. So when we developed this platform, it allows them now to give the signal to the hotel. And then what we do is we have a bunch of strategies in the background. One is reducing ventilation because we can watch CO2 and we can artificially drop the ventilation down. We can reset air handlers, fans, we can reset pump pressures. Because for a little while you can get away with a couple of degrees here, a couple of PSI here. And what we're able to do is we can knock a half a megawatt off their demand and they don't even know it happened. And now the utility has a customer, a half a megawatt customer that they can utilize and put into their demand response market. So the advantages that we're seeing of what Phoenix is doing, for example, in the industrial side, because their products are UL 508 industrial grade, but they have the Niagara platform to run in the buildings. Now we can bridge the utility, the industrial world with the traditional building world. Where in the past, those worlds never played well together. We talk about, Harun was talking about wastewater treatment and desalination. Well, because we have products now that are true IIoT that have Niagara in them that can talk to the building side, there's a lot of potential to really open up this smart city business. In the past, again, they were very siloed technologies. This guy didn't talk to this guy, and the traffic guy, and the wastewater guy, and the power guy. None of these guys talk to each other. And we're finding these huge opportunities because we've got an industrial platform that has an open operating system is that we're starting to see this much more homogeneous ability to control. So again, the flow goes, we get a signal from the control center. It goes through the ILC, through some logic, through whatever protocols we need, and then we can just start doing all kinds of fun things. And again, this is controls 101 over here. I'm not really going to focus on all that stuff, but just to say that there's a lot you can do to deal with demand. Are there any questions on this? I'm going to, as we go along. I know we got questions later, but as we go through the slides, please raise your hand if you have a question. I'm over my 3 minutes already too, so. This is a little bit more specific on the demand management devices itself. Some of the key customers, one example I like to talk about is AK Steel. AK Steel has a 200 megawatt demand. That's a lot of power. It's obviously a steel company, and what we allow them to do with this system is not only can we do demand response programs with them, so we're integrated into their SCADA system through Modbus. So we can take a signal from the utility that says, all right, we have an event this afternoon, I need you to knock off 20 megawatts. We feed that directly into their SCADA system. They don't even touch it. It just happens. And where that's come from in the last you didn't think of that 5, 6, 7 years ago. So they get the signals, it goes right in, they knock off a press or they knock off a rolling system, just like that. The other thing it allows them to do is bid into the market. So now think of a city and think of the interactions with the utilities and think of the big picture. They can now say, I'm going to bid in to this market. I'm going to bid 20 megawatts, I'm going to bid 30 megawatts, and I can give back to you from 4 to 6 p.m. today, and you're going to pay me for those 30 megawatts I'm giving back to you. So this is another program they can get into with the utilities, and they do that. And what we do is they get online and through their portal, they go in and bid into the market this afternoon. We got some excess capacity in our system. We're going to bid in 30 megawatts. It gets awarded. We take the award data, we feed it right back into their SCADA system. So if they say they bid in 40 and they got awarded 20, we feed the 20 right back into their SCADA system, and they can reduce their demand automatically. So again, all this interaction between the grid, between the utilities, between the building systems, and again, these are industrial customers, nothing to do with really a building automation system. Just some of the specifics. This is more product-specific stuff, but it does address how we go about it. One of the nice things about working with Phoenix is they're able to custom build products for us, not just the product itself, but an assembly. We actually used some of their assemblies, all UL 508 certified, that we can plop into generators, we can plop them into remote managed assets, and everything's there, the power supply, the terminal blocks, everything. So it makes installation easy. And this one happens to have a different manufacturer's cell modem in it, but one of the things about security is that we get into some situations where they have to be very secure, and Phoenix and Niagara have very nice solutions for cyber secure systems. So you got all this craziness going on in the background, and what does the customer see? So this is an example of a project. This is a net zero project in California. It's the Electrical Training Institute. We actually use this system for training electricians for next generation careers. And what we like to do is take a lot of data and make it simple. This particular chart up here, there's 4 lines you'll see that go across. That's a accumulation of 600 power meters in a building. So we take 600, we have 600 power meters in this facility. We actually monitor every circuit because it's a test and learning facility, and you really wouldn't pay to do all that. It's a little crazy. But what we do is we break the loads up into different kinds of loads. We look at HVAC loads, we look at plug power, which is what you plug in your walls, your computers, your toasters, your copy machines, things like that. We look at lighting, and we look at vehicle charging. So what we'd like to do is we have these lines running along, and this system happens to have a microgrid on it. It's got 4 solar arrays, it's got 3 sets of batteries. and it's got no backup generation. We actually use the microgrid and the batteries to back up the data center. So one of the things we have to manage during the day is in the mornings when they, in their insanity, they put electric boilers in. Not sure why, because they don't know how to spell natural gas in California. So they put electric boilers in, which what do you think electric boilers do in the morning when the heat comes on? You know, we're trying to warm the building up. Well, they get these electrical spikes. So we actually use the battery to chop off the demand. We actually use the batteries to chop that peak down in the morning. But what we have to be careful of is we have to keep the battery charged somehow before the sun goes down. We got to get the battery charged back up. Because if the data center, if we lose power at night, we have to be able to run the data center. So we have all kinds of strategies we have to implement for this project. A little bit about the vehicle charging thing. I don't have a slide on vehicle charging, but one of the hottest growing areas in the country right now is electric vehicle charging systems. The city of Los Angeles is electrifying their whole infrastructure for vehicles. Buses, police cars, maintenance vehicles, you name it, they're electrifying it. And they're putting in thousands and thousands of vehicle chargers. And they're not just the little Tesla ones or the little one you put in your house. These are doing buses that can charge a bus in 2 hours. So they're very serious energy consumers. So one of the opportunities that we're working with right now, we're actually looking at a nice development property in Philadelphia that's looking at the same infrastructure, is how do you create an infrastructure of vehicle charging systems? And it was funny, I was actually at a Tritium conference about 10 years ago. And the presenter got up there and he started talking. This was before, Tesla was kind of just getting started. And one of the things he talked about, he says, imagine this in the future. And this was 10 years ago. He says, imagine thousands and thousands of electrical cars, electric battery charged cars plugged into the grid. And imagine that that car is sitting on a plug for 8 hours a day. So you go home, you plug your car in, it charges in maybe an hour or two. So now you have a battery sitting there for 6 hours doing nothing. Imagine if you could take that, if you could manage the charging in a logical way, but if you had access to all that battery power in all those electric charged cars. Think of the lithium ion capacity you have with millions of electric vehicles on a grid. So one of the things we're developing now, what a lot of companies are doing now to be part of the green process and to be more energy efficient, is designing parking areas that are like little microgrids. They're going to have canopy parking, solar canopies over them. They're going to have vehicle chargers. They're going to have battery systems, and not in the cars, but a separate battery system or even a natural gas generator. That what they can do is when the vehicles come, whether they're buses or cars or whatever, they come in, they plug all in. Well, you're not going to ramp all your charging up at that one time. What you're going to do is you're going to use your solar or your battery to charge or to stagger the charges. And by the way, once those things are charged, you can steal from this guy and take it over here if you need some power. But you can manage, so instead of having one big battery, you have 1,000 batteries. So the whole management of that is something we are implementing as a product, as we're starting to develop solutions around this intelligent vehicle ecosystem. So when I talk about demand, it's not just buildings and it's not just plugging in your computer and things like that. This is a little bit of an eye test, I apologize, but another graphic, besides for the customers for nice pretty pictures and information, is the operational portals. This is one that we did for the Navy. It's a microgrid testbed for the Navy. One of the challenges the military has is power, obviously, in forward deployed bases. So if they have to go to some remote place in some country that they're having to operate, some theater of operations, they need power. And they're not going to wheel in, big generators that they have to drop in fuel, that caravans can get bombed, or pay a lot of money to drop fuel out of the sky in special tanks, or have generators that make a lot of noise that the bad guys can kind of find them really easy. They're working on renewable technologies where they combine solar, micro turbines for wind, and battery systems. So this was a test bed that we have with the U.S. Navy out in Port Hueneme, California, where we bring in third-party equipment. So we can bring in anybody's battery system, we can bring anybody's solar array, we can bring in anybody's gen sets, inverters, because of the advantage of the open protocols with the Niagara platform and its integration capabilities. We can quickly adapt to the new pieces of equipment, and then we have scenarios that we run everything through. So it's just a test bed. It's not a commercialized something we're selling. It's just a research environment for them. So my last slide is just some of the opportunities for a typical smart city and how you manage energy and demand. There's, I just did a couple quick examples. Back-of-house loads in hotels. We can dispatch renewable assets, microgrids. Integrating the manufacturing system, so looking at manufacturing loads and looking how we could shift production, shift operations, or how we can complement their operations with things like battery systems and different programs. HVAC lighting, vehicle. I talked a lot about the vehicle charging systems, ventilation equipment, discretionary loads. We can enroll customers and let them participate in the industry, the power industry, by letting them bid into markets if they have big loads. Again, it's not necessarily they're producing power. It's just by them lowering their demand is a benefit to the utility. So it's kind of we call it a negawatt. It's just a term. And then things like project financing. There are investors out there that will write checks if your project pencils. So if you can come up with a solution that saves the customer money and has an ROI on it of a decent amount, with today's economic situations, things like that, there's a lot of investors that are investing in this energy market, in this distributed generation market. So that's it. I know it was over 3 minutes, I'm sorry. But if there's any quick questions, other than we can talk this afternoon.